Sorry for the interruption. Let's pick up right where we left off. So we had just established that oxygen should have a -2 charge. And since we have 3 oxygens, we can calculate the total negative charge by multiplying 3 times -2. So we end up with a total negative charge from the anions of -6. We also know from the chemical formula that there are 2 chromium ions. So 2 chromium ions will give us a charge of -6. So just like a algebraic equation, we can remove the -6 from this side by adding 6 to both sides. So we get 2 chromium ions equals +6. Do the same thing we do for an algebraic equation, divide by 2 on both sides, and we get 1 chromium ion equals +3. So that tells us that our chromium ion is chromium 3. So one more time on how we did that. First, we find the charge of the anion. In this case, it's oxygen. Most anions have a very consistent charge, so we can use the formula, their group number minus 18, to get the -2 charge. We multiply their charge by the number of ions there are in the chemical formula, in this case 3. So 3 times -2, we get -6. Since we have 2 chromium ions to balance that, we can use algebra and the basic rules of algebra to isolate 2 chromium ions equals +6, divide by 2, and we get 1 chromium ion equals +3. So we know that in this chemical formula with chromium and oxygen, we have chromium 3. To write the name of that ion, remember, we just take the charge and we write it in Roman numerals. So it becomes chromium 3. Then take the anion, oxygen, take the first part and add IDE. So we get chromium 3 oxide is the name of this compound. So on your own, you can do a little practice by choosing the proper name for these 2 compounds, A and B. And then in a second, I'll show you the answer key, which you also have in your presentation. So this one should be iron 3 sulfide and copper 2 oxide. Now we're going to go from names to chemical formulas. So first thing we need to do is identify the cation and the anion, balance their charges, and then write the formula. So using the name, our first step will be to write the ion with its charge. So given the name here, potassium sulfide. Be careful with this one because there's also some polyatomic ions with similar names, sulfate and sulfite. So sulfide, anything that ends in IDE is typically a single atom ion. So potassium sulfide. So first we want to write potassium as a atomic symbol with its charge. So K, and since it's in group 1, we know it has a +1 charge. Sulfide comes from sulfur, so it'll take a little time before you're comfortable going from the name of the ion to the name of the element, but you'll just have to practice that a little bit. So sulfide is S for sulfur, and we look at the group number, 16 minus 18 equals -2. So our charge for sulfide is -2. Now we have to balance the charge for these 2. So since potassium only offers us a charge of +1, but sulfide has a charge of -2, we're going to have to multiply one or both of these by some number. The easiest way that I think to do this is to use the harpoon system. So if we have potassium here, and we call this a 1+ charge, and we have sulfur here with a 2- charge, we take the charge and harpoon it down to the bottom of the other ion. So this then can be written as K2S1, but we don't need to write the 1, so we can leave that out, and it just becomes K2S. So again, take the charge from above and write it down as the subscript for the other ion, called the harpoon system. We can check to make sure that our work is good by using basic math. If we have 2 potassium ions with a charge of +1, that's a total of +2. And if we have 1 sulfide ion with a charge of -2, that's a total of -2. And when we add these two together, we get 0. Good. We're set. If we have an ion that has a charge in it, things are even easier. We don't have to look at the periodic table. They already tell us that this is iron 3. So we need to write the ions for both iron 3 and chloride. So iron 3 is just the atomic symbol of iron, Fe, with a charge of 3+. And chloride comes from chlorine, so we write the symbol for chlorine and look at the periodic table to see that chlorine is in group 17. So 17 minus 18 equals -1. So write the charge above. Now we need to balance them. So again, we can use the harpoon system. So take the charge of iron +3 and write it down below for chloride.
Good morning, HIS elementary students. Literacy week has begun and it's that time.
Sorry about that. So we've taken the 3 and written it down for the chloride. We've taken the 1 for chloride and written it down for the iron. So once we cancel those out, we can see that it's iron 1, which we don't have to write, and chloride 3. So FeCl3. It's that easy. So go ahead and take a minute to find the proper chemical formula for copper 1 nitride and lead 4 oxide. There it is. So we have 3 coppers per 1 nitride, so it's copper Cu3n. And since lead has a charge of +4 and we have 2 oxygens, to balance that we have PbO2. That's all.